Hello, my name is Demetrius Bullock. Thank you for joining McAfee SIEM 101 training course. Today we will go over 4 sections during the course. That'll include an introduction and overview of SIEM. The next will be basic architecture, as well as some form factors of what SIEM offers. The next piece we will go into is use cases. And lastly, we will go into what value drivers SIEM can provide. So starting off, what is SIEM? SIEM gives the customer the ability to calculate baseline activity so that way analysts know what is normal versus abnormal. It provides a rule-based or rule-less correlation to detect known and unknown threats. It collects and correlates contextual information, not only from just McAfee products. It also provides a proactive risk and threat detection, all within one manageable console. Next, we will go over some core fundamentals that SIEM can provide. So in this example, SIEM provides 3 core fundamentals. The first is data source integration, which will include not just McAfee products, but also third-party vendors as well, which provides real-time visibility into what is happening in the environment. And with that, it provides a simplified operations in terms of one single console for management should there be an event or an alert that happens in the environment. With these 3 core fundamentals, customers can easily obtain, intervene, and protect their systems. Some noteworthy functionalities of SIEM is that it is able to be scaled diversely, not just between a small data center, but also expanded out globally between large data centers. This in turn gives the organization the ability to manage all of their devices worldwide in a single console, to be able to push policies to streamline and ensure that their systems are in a baseline configuration. These settings also provide a disaster recovery should one of the main systems go down. The customer is then still able to assign the policies and still protect their entire enterprise. As discussed previously, here we can see kind of a breakdown of the 3 core SIEM groups. The first one is data source integration. And as you can see from this list here, we not only integrate with McAfee products, we also integrate with other products that might be in an environment. For example, like a Brocade switch, even including items such as Titus. The next piece that we will discuss is infrastructure. This includes some components as well as some features and functionality. Next is operations, and how the analyst takes those alarms and events and strategically places them into policies effective around the enterprise. Jumping right into data source integrations. First, let's start with what customers have to say. They have other security products in their environment, and they're curious on how to have a single management console to be able to view events from those. Again, not very many vendors offer that. However, McAfee Enterprise Security Manager, or ESM, has the ability to have a multi-tenant single console access to events and to be able to create remediative actions across the enterprise. Now, some customers are curious on how they would integrate those multi-platform integrations, and is it really needed? The answer to that is yes, because the integrations reduce the mean time to detect as well as the mean time to react. But what does this mean for the customer? In short, this means it gives them the opportunity to quickly and effectively handle any possible data breaches or malicious activity going on their network. They do that by allowing the data sources to come into one focal point, and it gives greater visibility into their enterprise and to be able to correlate events to see if the attacks happened on multiple systems or if one was just an isolated incident. But how hard is this to actually set up an environment? Does it take a lot of time? Is there a lot of overhead into this? these are some of the questions that customers ask. So let's go ahead and dive in to see what it actually takes to add a data source. So here on the ESM console, this is the login. You're going to go ahead and click the menu on the top left and go down to configuration. Once you're at configuration, you'll choose properties. You'll go ahead and click on data sources. Now in here, there's some pre-built for this environment. So for example, this customer has a Cisco VPN. So if we go ahead and take a look inside, we can see that the data source vendor is Cisco. We can see that the source model is ACS, and you can see that there's different options. They can choose a wireless LAN controller, TACAX. It just depends on how that particular system communicates. You can see the data retrieval is syslog. And in this environment, you can choose the different ports that it goes to connect. We also have a McAfee web gateway, for example, in this environment. And it's very easy to configure. All you do is you go to the vendor, choose McAfee, choose web gateway, and then the data retrieval is just syslog. You'll ensure parsing is enabled. You'll type the host name and then the IP address. And then also built in, you can do an IP lookup if that name is in the DNS, and it'll pull it. Now let's say that you have a device that you want to add. So let's go ahead and go into the steps of adding a new device. So here we'll just click add, and we'll drop down and look at some of the vendors. As you can see, this is quite an extensive list. There's ArcSight. As previously discussed, there's Brocade, Blue Coat as well, Beyond Trust, Cisco, CyberArk. So there's a lot of different multi vendors that ESM is able to tie into. Google as well. But let's say that our customer has a virtual environment that they're using, for example, VMware, and they have a vCenter. So let's go ahead and choose VMware, and then we're going to go to the vCenter server. And so with this, we're going to use just the default API integration. As you can see, there's multiple ways of pulling events, but the API is recommended. And we're going to ensure that parsing is enabled. We're going to choose the name, the IP address, and then also a designated username and password for connecting. Now, if the customer had an SSL set up, we would use the SSL, ensure the port is correct, and then we can even test the connection. And then once the test is successful, all you would have to do is just hit OK. Now that we've dived a little deeper into how to configure SIEM, let's take a step back and look at some of the features that SIEM actually provides the analyst and customers. Here in this example, you can see that SIEM provides a centralized location for log collection, as well as log analysis, event correlation, and we're going to skip log forensics and IT compliance for right now. It also does log application log monitoring, object access auditing. Now a question is, can SIEM provide real-time alerting, user activity monitoring, dashboards, and can it actually provide reporting? We will dive deeper into those as we continue. SIEM does provide file integrity monitoring, system and device log monitoring, and log retention. Now with all of that data, SIEM gives the analyst the ability to do log forensics and ensures that the company is adhering to IT compliances. With that, let's dive a little bit into the infrastructure and get a better knowledge of how that happens. So starting off, we have at the centerpiece, we know a SIEM. Next we have the McAfee Enterprise Security Manager, or ESM, which provides the centralized management console for the admins to look at all the logs. Now in order to receive that data, they need the McAfee Event Receiver, which provides the key focal point for all the data sources to point through. Next, they need a correlation engine, or ACE, to correlate all the events as they're coming in to give a unified look inside of ESM. Next, all the data logs are sent to the ELM, or Enterprise Log Manager, and that is where it is all the logs are stored. Another piece is the McAfee Enterprise Log Search, or ELS, and that just provides an enhanced search into the logs. And you also have the Application Data Monitor, which is ADM, and that gives a look into applications as a baseline. For SIEM, there's only 4 main minimum components to stand up. For example, a small business just starting out. You have the McAfee Enterprise Security Manager, the ERC, the ACE, and as logs come in, you will need the ELM to store all that raw data. So switching gears, let's dive into operations. For operations, we're going to cover 4 common features found within ESM. First, we'll dive into notifications. Notifications are a fully customizable as well as a fully automated email notifications. So when an event occurs, the ESM can set an automated email to designated individuals or an email group. So here, for example, we're going to look into an alert that comes into the ESM. So starting off, it shows that an affected user has happened. So clicking on it, let's go ahead and look at view details, because we see that it's a rule correlation event. So you have a choice of either acknowledging or diving into the details. So for this particular, we're going to go ahead and dive right into the details. So we'll click view details. And this field is what comes up. It shows that an alarm was triggered due to a rule correlation. You can see under rule message, it says that there's a multiple advanced threat detected. So we're going to go ahead and click on the view details to kind of dive in a little bit deeper. In there, you can see that there is 4 groups: details, description, custom types, and geolocation. So inside of details, we can see that it's an ACE rule correlation. We can see the source IP as well as the destination IP end. We could also see the user. So let's get a little bit of message on what it is. Under description, it shows that indicates that there's malicious software activity. Well, that doesn't sound very good. As you can see, it's just a brief overview, so let's dive into a different view to show more detail. So under custom types, we can see the application is Mozilla. We know that the user, and you can see that the reputation is a minimal risk, but looking at the URL, that doesn't look like a normal URL that we would be using. As well as the threat name shows that it is using a W32 Zeus.az executable, which is not a normal baseline executable. So let's look at the traffic. Under geolocation, it shows that the source is in Texas, where the user sits. However, the destination end is showing in China. So for that, we know that this instance is probably a malicious event, and we'll go ahead and create a ticket. Now, I will dive into that a little bit deeper later in some of the use cases. So diving right into our next topic, which is reports. These reports are customizable, and there's also some pre-built reports already in ESM. Now, some of the nice features is that to reduce some overhead that admins sometimes run into, which is getting reports for their executive chain, they can build an automated process for it to be emailed to an individual person or group email on either a daily or weekly, basically a scheduled time frame, so that way they're not having to do it all the time. So here's an example. Starting off with the menu, you go ahead and click reports, and a new window will come up. So in here, all you can see is under system properties, you'll just go down to reports, and then you'll just go ahead and click add. Now here you can create the report name, give it a description. Again, if you need to schedule it for a time to be ran, whether it's daily, weekly, or hourly, or if it just needs to be run as a manual process, you can go ahead and choose that here. And then as you scroll down, you will have different options to choose what kind of reports, whether it's a dashboard that you might already have pre-built, like for example, if it's disabled logons or disabled accounts that are trying to be logged on. Sometimes that's useful in a report, especially for setting it to like a security manager for them to see, like if a person has left the company and they're trying to, still access information, then they can have a precedent to go to legal and be like, okay, well, this person is, attempting to still access some information, they can handle it at that point. In addition to reports, it also gives threat and risk prioritization. It gives the ability to have continuous monitoring for identifying threats and automating how some of those threats are handled. There's also a centralized dashboard for being able to visibly handle those events and being able to correlate event information against threat feeds, such as file reputations. So kind of going into our next topic, which is going to be dashboards. With ESM, it comes pre-built with some dashboards already built in, but the dashboards are fully customizable. Now, if a customer already has an ESM pre-built in their environment, they can export the queries from their previous ESM and just import it into the new. The only thing going from an example from like 10 to 11 is they need to validate that some of the parameters are still the same going into version 11. Otherwise, when you import a dashboard, it might not come up all the way. So some of the benefits of the dashboard is pretty much risk assessment. It reduces the time for threat identification, and especially if you need to look at how many systems are non-compliant within an environment. Moving right along to our next feature, which is continuous monitoring. Now with continuous monitoring, this is achieved with ESM's ability for real-time collection, analysis of logs, events, and flows. Real-time compliance monitoring dashboards complete statistic reports and provide analysts with an instant view of the most up-to-date and compliance posture. And with the continuous monitoring, it reduces compliance costs by decreasing the total time and effort needed to understand applicable mandates, continuous monitoring status. So with that, let's go ahead and test what you guys have learned so far. And welcome back. Hopefully that test was not too difficult, and I appreciate you guys' time in taking that quiz. So moving along, our next section is architecture. So what are some of the best options for standing up a SIEM? For example, I'm a new customer. Is it fully scalable? And the answer is yes. SIEM has the ability for full scalability from a small business just starting out to a worldwide large organization. But what hardware would the customer need to be started? For example, what benefits does it provide? So let's go ahead and take a look and see what benefits that the SIEM actually does provide a customer. So diving into each piece, starting off with the McAfee event receiver, we can see that it provides endpoint visibility and data collection, right? Because this is the receiver for the central point where all the data is sent to. And it's scalable to match enterprise growth. So if a company gets a bunch of new systems and assets, you add that with the McAfee Advanced Correlation Engine. It is a rule-based or rule-less correlation. It also has the ability to be configured in real time and historical threat detection. So as events are coming in, it'll correlate real time, or settings, you can have it check historical events. And couple that with the Enterprise Security Manager, which provides the single management console to analyze the threats and the single point for applying policies to protect, as well as creating automated analysis and automated notifications to the correct people. There's no loss in time during that point. And with that, all of these powerful pieces together provide a simplified and powerful threat detection, investigation, and response. And it also provides a data visualization, which reduces the triage time, right? The mean time to detect to the mean time to react, to help analysts quickly understand and respond to threats appropriately. This kind of takes the hands-off approach for the analysts, especially if they're looking into the real time or historical, they can see, where certain systems might have been affected. So let's take a look into how the historical settings for ACE is configured. So here we have a customer environment. The gray represents their data center. So inside their data center, they have a couple databases: Windows Active Directory, Splunk, as well as some network devices such as routers and switches. And outside of that data center environment, they also have customers that come in with laptops and desktops through a VPN. Now, inside the data center, we will carve out our own McAfee environment to give them their ESM, ERC, ACE, and ELM. So once ESM is set up, it'll set the data points or the data sources to have ERC begin to pull and retrieve the event data. From there, it sends the raw logs to ELM, and then it sends a parsed data to the ESM. Now ESM then takes that data and sends it to ACE as a request, saying, hey, I would like this correlated data for any events that match this. ACE will then go into the ELM doing a historical search and then present ESM with all of the relevant data if any of those events matched. Now let's take a look in some ACE real-time correlation and how that's set up. So we have the exact same environment with ESM, ERC, ACE, and ELM in its own location. The data sources are still set to the same. Now the raw data is still sent to the ELM. However, this time the parse data is sent to the ACE. And ACE will then automatically reach out to ELM to get any information that there might have been a previous attempt, and then it packages it and then sends that correlated data to ESM. Now the only difference between this is with historical settings, ESM tells ACE to go out and reach it. During real-time correlation, the parse data is sent directly to ACE, and ACE handles it on its own instead of as scheduled. The raw data still gets sent to ELM, whether the configuration for real-time or historical is set differently. And again, ELM is just the raw data log holder for this ecosystem. And with that, that is the difference between real-time correlation and ACE historical correlation. So now that we have a better understanding of how the architecture actually looks between historical and real-time correlation, let's go ahead and dive into how that is actually configured with inside of the ESM. So here, we'll log on to the ESM. We'll go to the top left, which is the menu, and then we'll go down to configuration. Now going over to the ACE, we'll select ACE and go to properties. And then as you can see under historical, that is where we would actually tell it to go into historical mode. So if we go ahead and click it, it'll tell it that it'll disable the collection of all future events. So when you do historical correlation, you must ensure that you predefine specific filters for it to look through. To change it back to real time, all you need to do is go to historical, uncheck historical, and then re-enable the correlation manager by just selecting and clicking enable, and then apply and OK. And this will reconfigure the ACE to now point back to real-time correlation. And just click yes and apply the settings, and it'll push the policy out to any other corresponding ACE as well. And that is how you configure an ACE for real-time or historical. And welcome back. So with McAfee SIEM, there are some additional appliances to improve functionality. For example, we have the McAfee Database Event Monitor, which uses a passive network-based monitoring for zero impact on the database, and it retains details of database transactions, for example, log in, log off, to help support for auditing. Next is the McAfee Advanced Threat Defense, which breaks down the execution chains for malware. In turn, it pretty much gives the SIEM a true sandbox testing environment to take executables that might be malicious and to spin up a VM that can host the operating system and then the ATD will then take all the information on how the executable reacts and what it touches, and then it takes all that information and presents it to ESM. The next piece is McAfee Threat Intelligence Exchange, or TIE, and this provides file reputations from the global threat intelligence. And what it does is it gives file reputation to local sources, including endpoints, gateways, and advanced analytical solutions. So here is a breakdown of how the architecture look if all the appliances were put in together. At the top, you still have the ERC feeding in all the data to the ESM. And then the ESM would then send the different pieces or the parsed data to the different applications, such as ADM or the ATD. And that is basically a architectural picture. So with all that, let's see how you would add some of those devices. You would log into ESM, and then you would get to configuration, and then you would click on the button that says add device. You would choose what the device is, enter in the information such as IP and hostname, type in the password for that device for the root account, and then once it establishes connection, it'll automatically key the device, and then you are all set to begin configuring that specific device. So with that, let's see how it all ties in together in a customer environment. So for this example, we have a PC that opens up a malicious file or executable, and that's designated at number 1. From there, it is triggered in an event, and then the event is then sent to the receiver. Now the receiver takes that raw data string, right, and separates it. For the parsed data, it begins to correlate, okay, it's malware, and then the normalized string that it's going to send the ACE, or the parsed data, is going to say malware, Trojan, and then it takes that data and then sends it to ACE. ACE then takes the correlated data and sends it to ESM. ESM then takes that data and sends it to ATD. ATD spins up an environment to match where it came from, and then it takes all the data, it checks it against TIE to see if there's any known reputations on that file, whether it's malicious or unknown, and then it sends all that data back to ESM, where the analyst can determine what to do with that specific executable. Inside of ESM, they can create a case, and the EPO administrator then at that point can create a policy that will block future executions of that particular file. A system tries to launch it again, this will already have the reputation to say that that is a known bad executable and won't be allowed to launch. So with that, let's move on to our next section. Is HA in disaster recovery a possibility? Does SIEM support high availability or disaster recovery solution? And the answer is yes. SIEM supports both HA and DR solutions. This is natively built into SIEM. Now the question comes, what hardware would be needed to start this, or to have an HA or DR solution? In the next couple slides, we'll break down kind of some small examples of what you could use as an HA or a DR solution. So starting off with this slide, this is set for a high availability, where you have the primary data center and the secondary data center. Now at the primary data center, you'll have the ESM set as the parent. Also at the primary data center, you'll have an ERC and an ELM. And then of course at the secondary data center, you will have an ERC and another ELM as well. And at the secondary data center, the ESM will be configured as the child. So what this means is that as policies are updated in the primary ESM, it is then replicated to the child ESM. So if there's certain flags or certain warnings, the child ESM will also pick up those as well. And that way, as it sends the data, for replication, both ESMs will have those alerts as the data is coming in. Also, in a high availability, if you're upgrading, you always do the primary data center first, ESM, and then the secondary. Now for the ELM replication, as live data is going into the primary data center's ELM, it is then being replicated to the secondary ELM. And this just ensures that both sides have it at the same time. And like I said, that is a live replication. So with this, it also gives the opportunity for clustering ESMs. Now, there is a slight difference between 10x and 11, so let's take a look into that. During the next course, we're going to go over what the difference is for clustering in ESM 10 versus 11x. So with the introduction of ESM 11, there are some new features that has come into play. So here you can see the architecture, right? This is an example of what the ESM 10X currently looks like. ESM is still the main center focal point for where all the data initially traverses. And this configuration is a pre-distributed ESM architecture. So as in there's no clustering, no additional ESMs that it configures. So what are the requirements for the new 11.x clustering for ESM? And on the next slide, we'll take a look into what is actually needed or highly recommended for upgrades. As you can see, starting off from the data sources, the information travels to the receivers and now travels down to a data streaming bus or a DSB. Now the DSB is a virtual appliance that comes at a no additional cost. And what that does is it acts as a communication bridge, and it sends the information to the ESM and all the other SIEM appliances. Now the data streaming bus is a requirement for ESM 11.x. Next, we'll go into disaster recovery and how that architecture comes into play. So best practices for this architecture is assumed that full backups for the ESM, ERC, and ELM are saved in an offsite or separate location. And this is done either as a full weekly with differentials. Now, This assumption is that the primary data center, where the SIEM appliances currently sit, is suddenly having an issue, whether it's flooding, fire, a natural power outage. So the recovery plan is to stand up their cold site and restore the ESM, ERC, and ELM from the backups. And again, that means that there's no connection to the data center or to the other SIEM appliances. So when the restore is complete, those ESM, ERC, and ELM from backups will have the same IP address and configuration as the primary data center did. And from there, it'll handle the traffic that originally was happening in the primary data center. And now the secondary data center will act as a primary, and the primary is the cold site. So moving into our next section, the question is virtual or physical? So here we have a customer that says that they're not ready to add another physical hardware to their environment, as it might cause them too much overhead. And they're asking, is there anything else that it can be? The simple answer is yes. Some of the SIEM hardware and appliances can be virtualized. For example, vCenter has a VM, and they're ready to configure and deploy. On top of that, SIEM has also made available on the cloud some appliances as well. So if you have a customer that's migrating to the cloud, this might be a good place to segue into. SIEM also has appliances that can be in the cloud as well. Then the question still comes, is virtual the right move? So here, for example, you can see all of the SIEM appliances on the left-hand side. We have ESM, ERC, the ELM, as well as ACE. And in the next column to the right, you can see, is it virtual capable? And that indicates whether you can import it into vCenter, deploy it on an ESX, and the answer is yes to all the appliances. Now, on the far right side, these are some of the cloud locations that SIEM currently is supported on. Now, I will segue into that. ATD is not supported on AWS. It is not supported on Oracle Cloud. Now, with going into a virtual environment, the events per second is not as significant as if it was a physical device. So as you can see for ESM, for example, in this particular configuration for virtual, it can only handle 75,000 events per second. Whereas the EPS for a physical is 400,000. Now again, this will vary based on different compression ratios and how many core CPU that the virtual device has, as you can add more cores to the virtual to kind of help. But as you can see, from a physical standpoint, the physical devices can handle more events per second. But for a customer that's starting out and only needs a small SIEM, a virtual might be the best route for them to go. Making our way into the next section, we'll go over 3 individual use cases on how SIEM can help in certain situations and what information that it provides. So in the first use case, we're going to go through advanced threat detection. So, for example, here is a picture of the dashboard, and it's showing some threat events with the average severity as high. Now the scale goes up to 100, so a 97 is obviously pretty high in this event. Now this is an event that was triggered inside of ESM. ESM has identified a system that is showing signs of suspicious activity through an application that was tested in the ATD. So let's kind of dive into what was showing inside of that event. So upon clicking into that warning and drilling down into the events, here we can see that the individual user has plugged in a USB device. Inside of that USB device, they begin to launch a corporate payroll XLS, so an Excel spreadsheet. And from there, the next pieces are the notifications. So once that ran, a rule correlation kicked off showing that there was malware. And then that malware was sent to ATD to be tested. And during that time, in the GAM engine, it was found to be malicious. So here is how SIEM creates automated notifications based on what ATD discovered. Next, we will dive into what other source IPs were affected or launched the exact same corporate Excel spreadsheet. And as you can see, it identifies all the systems that run that particular instance, and that's due to ACE correlation being able to find the different IPs. And it breaks it down easy for admins to be able to look at. And from this information, they can go and add tags to quarantine the systems, and that way to lock them down. So a quick recap of the first use case. ESM provided a tool to quickly handle and adapt to security policies to ensure that no spread of malware to systems. They were able to identify the malware quickly, and ESM provided an automated solution for creating notifications and blocks. This also reduces the possibility of a data breach because it affected more computers as well. So now I will demonstrate what it looks like on the actual ESM console. So first we'll go ahead and log in to the ESM itself. And as it loads the dashboard, you can see under average event severity, there we have the multiple advanced threat detection. So we'll click on it, and now it shows us one event source for a user. So we'll right click and go to summarize, and we'll go ahead and open it up in a summarized ESM view. So here we can see the events breakdown. We can see that the device is plugged in, what was open, and we can see it all the way stretched down to where it's actually tested in the ATD. So now we want to see what other systems or users might have been affected by this. So we'll right click the removable storage protection, go to summarize, and then we'll scroll down to summary, and we'll do signature IDs, and this will isolate those specific signatures. And in the summarize view, we'll go ahead and do the same view, the demo ESM. So there we saw that if we right clicked and did a summary of that signature ID, now we can see all the individual users that were affected by the exact same Excel spreadsheet. And luckily we caught it at a good time that there was only 4 users that had accessed it. So with this information, we can also see the IP addresses listed below. So what we can do from here is now we can put these systems into a quarantine status. So we'll go ahead and right click, and under Actions, we will go to EPO tagging. In the new window here, you can see kind of a list of different tags that we can actually apply to those systems from ESM. So as you can see, we can do a filter suspicious system activity, block web traffic, lock down endpoints, and even initiate an aggressive antivirus scan. So for this individual instance, we will go ahead and do a lockdown the endpoint. We will also do aggressive scan, and we will identify the system as infected. We will ensure that we click on Wake Up Client, and then we'll go ahead and click the Assign Tags. This will assign the tags in EPO. And then once we click that, we can go ahead and close the window. So now we want to create a watch list for these users, just in case if they try to access, something similar to that again. So we'll go ahead and right click on the username, Actions. And then we'll go ahead and append to a watch list. Now, as you can see from this side, the username will appear here, and then we'll go ahead and select an actual watch list to apply them to. And for this instance, it'll be the demo suspicious users. Next, we will be going over non-business web activity. And this will cover some policies that are in place at an organization. So, for example, under the average event severity, we'll see that there is the high volume of non-business web activity. And this is based on a custom rule that's defined by an organization. So as you can see right here, we'll click on the high volume of non-business web activity, and then we'll go ahead and we will drill down into that event to see what is going on, just as we did with the ATD. So when we click on it, we can see in the event distribution, the times and the amount of times that an individual user has attempted to access websites. And then breaking down that specific summarization, we can actually see that we can separate it from right is source user, then the middle is the websites that they are accessing, and on the left is the category of what each of those websites are. So as you can see, we have the one user, and then under the hosts, we can see that he is accessing, like for example, E-Trade, eBay, some news websites, Facebook, and ESPN. And then on the left side, we can see how it breaks down those categories of each. And we can see that it has sports, humor and comedy, auctions, stock trading, forum, news, social networking, and sports. And with this, an EPO admin is able to block some web traffic based on policies that they can create just from this information. Now let us transition to a walkthrough of this use case. So here, we'll log into the ESM, and you'll notice under the average event severity, there's a high volume of non-business activity. And so let's go ahead and drill down into that. Here we can get a list of web domains that are currently being accessed. And if we click on this information, we can actually see the source users that are trying to access this. Now, if we wanted to create a watch list for that specific website, all we would do is either just create watch list or append. We would choose it under type as web domain, and then if we had that category, we would choose a watch list for it. Now let's say that you would like to drill down into more information, maybe separate it based on category. So you would go to the event distribution, click on the three dots, and then you would scroll down to category. And here it'll actually break out a list of categories for what each of the websites are. As you can see, for example, there's entertainment, sports, job searches. So that way we can identify which users are spending their time, possibly even looking at jobs outside of that organization. Now to get the source user for this, we would just go in the category, go into drill down, event drill down, application, and then we would click source user. Now let's click into different fields such as sports. And when we do, it changes and shows us who is accessing those websites and how many times. And if we wanted to create an alert or put those specific users on a watch list, we would just right click in actions and then either add or create a watch list. For this example, we're creating one. So we're going to type in non-business, just so that way it's easily identifiable. And then you can see that the user is selected. Now let's say you have a group of users that you want to append to that specific watch list. You would simply click all of their names, go down to actions, and append to watch list. And as you can see, all their names appear now on that list, and then you add them to the watch list. Click save. And now all those users are now in a watch list. So anytime that they access those specific websites in that category, admins will get an alert, and that could be a printable source to turn in. Moving right along, we're now focusing on Windows Users Activity Monitor for our third use case. So in this example, we have a customer that has a new policy that's gone out about disabled accounts or disabling accounts after 45 days. And during this time, a supervisor is asked to get a record of how many events or attempts for disabled accounts have happened since then. As you can see on the right hand side under noteworthy events, the disabled account logon attempts is 2,586. It gives a quick, presentable, usable display for the admins, and they in turn can easily report those numbers to their security manager quickly and reliably, as all this data comes in. Now when you click into that specific instance, there is a breakdown of what user accounts are attempting to be accessed. So for example, we have this user, Patrick Duff, who's attempted log on 13 times. So if we drill into that, we can look to see the event times when the account was attempting to be accessed, and also how many times the account was accessed as well. So here we see that it's around 2 to 4 o'clock. And inside of that information, not only does it give us the hours on when it was accessed, but it also gives us the source IP. And with that information, we can tell if an account has been compromised and act accordingly. So starting off on our third use case, we'll go ahead and log into ESM, and under average event severity, we will see successful Windows brute force login. And let's drill down into it. And here we can see an account is being attempted to be accessed with an expired password. If we break it down, we can kind of see the timeline. So we're going to go down to noteworthy event distribution, and we notice that it's every hour and always 2 times. So we're going to look next to see if there was any successful Windows brute force attacks. And according to this noteworthy event, it shows that there was 24 successful. Obviously that is a bit concerning, so let's go ahead and click into it. And if you see here, it shows all the users that were successful. Now we have our current time range set for 48 hours. So if under noteworthy event distribution, we can actually zoom into that time to kind of get a better idea of how many times and how often that event occurred. So we notice that it's a little bit between 6:50 and 7 o'clock in the evening. So let's drill down. So we're going to go to the events. And here with this information, we can actually see it come from the source IP of .01. And in this window, it gives us the information of the signature ID, the IP address, and we want to see the location where it's coming from. Here we can see it's coming from California. And then also under custom types, we can see the user that's being attempted, as well as where the host is that it's coming from. So we see that it's from the Active Directory server. These source events give us the event count and how many times that it was accessed. So here in this example, this one is a successful, so that is why there's authentication ticket granted. So if we drill down into one of the failure ones, this one we can see coming from a different IP address. So here we see that the source user is a different name, and also that the host is from a kiosk. So we switch to look at the geolocation. We notice that it's in New York City. Under description, it gives us just a quick, brief overview of what that is. So now we need to drill into a little bit deeper of the failures. So again, on the right hand side, it shows failure, and then it also shows the source IP. And we can see that this system might be compromised or someone is trying to access it. So that's why we go into actions, and we're going to tag this specific system to block the traffic coming out of it. And so we're going to lock it down and assign the tag. In this next section, we'll be going over the value drivers of what McAfee SIEM can provide. This section is more tailored towards the sales aspect instead of the engineering aspect. So here, for example, we can see some of the discovery questions towards potential new customers. Does their current company have visibility to prevent becoming another global breach headline? Do they have the ability to quickly and easily get the security intelligence needed to investigate and resolve incidences? And is their current solution a smart, fast, and able to automate threat response actions across multiple security infrastructures? And here are 3 categories why McAfee SIEM is a good solution. It provides a single point. It consolidates SIEMs that might be geographically separated into one location. And when I say one location, I mean one console to be able to provide remediative actions across the entire enterprise worldwide, instead of having to go to each site. The next category is automated tasks. When alerts are triggered, the right people are automatically notified in a timely manner. This also reduces user error of not communicating an incident on time, and instead creates a workflow that is visual and trackable. The third category is reduced. It reduces total cost of ownership. And it does this by automated triggers and alerts that reduce admins chasing white noise alerts. For example, if a system is running an outdated version of Firefox, instead of that analyst going and trying to track down that single system thinking it's malicious, they would instead be able to actually investigate a real potential malicious event. Next, SIEM provides a detect and act on threats faster, using agentless collection and analyzation of events. It also provides near real-time investigation of possible malicious content, and as we stated earlier, the automated alerting notification. With all this, it gives the customer the ability to do more with existing staff by correlating the history of events and being able to display it in a very digestible screen for them to see all points. And unlike other SIEM vendors, McAfee SIEM does not drop events if they reached a license limit. McAfee SIEM does licensing based on the hardware that it can handle. For our 5th and final section, here we will go through some additional information to help better understand what SIEM can provide, as well as give some testimonial to what the SIEM solution offers. Here we will just cover 2 categories. The first category is going to be the Gartner peer review. Now here we did some comparison between McAfee, SolarWinds, and Splunk. Here you can see that we are currently rated at 4.6, SolarWinds at a 4.4, and Splunk is also at a 4.6. Our biggest key indicator is the willingness to recommend is 90% for McAfee, while SolarWinds is for 57%, and Splunk is 89%. Our product capability rates at a 4.7, with real-time monitoring beating Splunk. For threat intelligence, we beat both SolarWinds and Splunk as well. Next, we'll review behavior profiling. And here you can see that McAfee SIEM beats out SolarWinds and Splunk. For the data and user monitoring, we are tied with Splunk, as well as for application monitoring. Under analytics, we beat SolarWinds. And for deployment and support simplicity, we rate above both. Next, we will dive right into some customer testimonial. As we can see from the Gartner's peer review and some of the customer testimonial, McAfee had been the top choice over other competitors based on its pure simplicity, ease of deployment, and its ability to take in multiple data sources and present vital information in a timely manner. Recovery after a data breach is hard. CEOs are always trying to find the best route to correct and analyze information. At McAfee, with our SIEM solution, this is what we provide. We take the overhead and all the extra hard work and put it into one simple format. Thank you guys very much. I hope that this training was informative, and I look forward to having you in future trainings. I'm Dimitri, signing off.